Welcome to Get Your FRQ On. This question is from 2005. It is question 4, and it is not calculator active. In the question stem, we're given a function f and a bunch of information about f in a table. We have information about f prime, and f double prime all in the table. We have specific information about what happens with x equals 0, x equals 1, x equals 2, x equals 3, and what happens on the intervals in between those integers. And the function f is defined from x equals 0 to less than 4. We're given that f is twice differentiable, which has its own implications, which we may need to take advantage of at some point in this question. But for part A, we are to consider x between 0 and 4 exclusive and find any extrema, determine the type, and to justify our conclusion. All right, we're given that the function f is continuous on 0, 4, so f could have an extrema for some x, where f prime of x is equal to 0, and changes sign, or at some x such that f prime of x doesn't exist but does still change sign. All right, by looking at the table that's provided in the question stem, there is only one value of x for which that description would be accurate, and that is at x equals 2. The function f will have a relative maximum at x equals 2 because f prime of 2 does not exist, and f prime of x does change from positive to negative at x equals 2. In part B of this question, we are asked to sketch the graph of a function that has the same characteristics of f. Now, this is going to require a lot of use of the information in the table provided. For example, there are 4 points that we know for sure about f of x based on the table. F of 0 is negative 1, f of 1 is 0, f of 2 is 2, and f of 3 is also 0. Then we can check the different intervals to see whether or not the derivative of f is positive or negative, or whether the function is increasing or decreasing. So if we look at the table and try to ascertain the direction of f prime of x based on the table, we can see that f is increasing between 0 and 1, increasing between 1 and 2, decreasing between 2 and 3, and decreasing from 3 on. Next, let's look at the behavior of f double prime of x. All right, so if we let the red arrows indicate the direction of f double prime of x, between 0 and 1, f double prime of x is decreasing. Between 1 and 2, it's increasing. Between 2 and 3, it's decreasing. And between 3 and 4, it is increasing. All right, so what this tells us about the function f is between 0 and 1, the function is increasing but concave down. Between 1 and 2, it's increasing but concave up. Between 2 and 3, it's decreasing and concave down. And between 3 and 4, it is decreasing but concave up. All right, so taking this information, along with the fact that the derivative of f doesn't actually exist at x equals 2, we don't want there to be a smooth curve at x equals 2. So if we take this information and try to turn it into a function, we should get a function that looks kind of like this. All right, we know that f prime of x at 0 is 4, so this should have slope something equal to 4. We know that the derivative at 1 is 0. We know it's not defined up here at 2, so that shouldn't be smooth. And just taking into account all of the different pieces of information that are in the table, we can get a graph that looks kind of like this, and this would have the same characteristics as f, at least the characteristics that are provided in the table. In part C, we define a new function g of x to be the integral from 1 to x of f of t dt on the interval, the open interval from 0 to 4. And then we are asked to find extrema of g to identify the type and to justify our conclusion. All right, so g of x could have a relative extrema anywhere that g prime of x is equal to 0 and changes sign, or g prime of x is not defined and changes sign. Well, based on the fundamental theorem of calculus, we know that g prime of x will just be f of x, and we know that f of x will equal 0 only at x equals 1 and x equals 3, right? That's from the table. Now, using this information, f of x will change sign from negative to positive at x equals 1, indicating that g of x has a relative minimum at x equals 1. And also from the table, f of x changes from positive to negative at x equals 3, indicate that g of x will have a relative maximum at x equals 3. In part D, we are asked to find any inflection points of g and to justify. Well, the graph of g will have an inflection point anywhere that g double prime changes sign. By the fundamental theorem of calculus, g prime of x is f, which implies that g double prime of x is f prime of x. All right, we established in part A that x equals 2 is the only value of x for which f prime of x changes sign. So, using that as our justification, there should only be one inflection point for g of x, and that would have to be at x equals 2.